Hello everyone, welcome back to our next section of online chemistry classes. In the last class we were dealing with our chapter study of compounds. In that we were dealing with HCl, hydrogen chloride. So in the previous session we were discussing chemical properties of HCl. We have discussed the reaction of HCl with a large variety of compounds like metal oxide, metal hydroxide, metal sulfate, metal disulfide, metal carbonate, metal bicarbonate and metal sulfide. So today we will be continuing that part. The next type of reaction that we will be discussing here, it is a precipitation reaction using HCl. So precipitation, what is a precipitate? A precipitate, it is a solid product that is insoluble in both the solution. So it is not if we add a solid into liquid, if that solid settle down, it cannot be considered as a precipitate. So how to get a precipitate? You have to mix two liquid. We are supposed to mix two miscible liquid, and the product must be an insoluble product. Okay, so such product is called a precipitate, and such reactions are called precipitation reaction. So if you want to react HCl with a certain compound to produce a metal salt, if you want to react HCl with certain compound to produce a product which is insoluble in both the solution, there is only one case, that is this. So as you have studied in the previous reaction, almost all the product using HCl, it is metal chloride. So HCl plus something, a compound, it will give metal chloride. So if it has to be a metal chloride, so it will be a compound of metal, and that metal must be insoluble in water. So if you want to do a precipitation reaction with HCl, the only thing that we have to look here, that is this, the metal chloride that is formed by the reaction of HCl and a certain metal or metal compound. This metal chloride that is formed must be insoluble in water. Okay, so when we are analyzing all the properties of metal chloride, there are only a certain number of metal chlorides that are insoluble in water. So the list of metal chlorides that are insoluble in water, the major one is AgCl, that is silver chloride. The next one is HgCl2, that is mercury chloride, and one more is PgCl2. These are the three chlorides that are insoluble in water. Okay, so what does this mean? It means that if we are taking a metal compound of any of these three metals, the product will be AgCl, HgCl2 or PgCl2, which will be insoluble in water, or in other words, it will give a precipitation reaction. So if you want a precipitation reaction, what you are supposed to do, react HCl with any of the compound of these three metals. You will get the metal, corresponding metal chloride, which is insoluble in water, and that will form a precipitate, or in other words, it will be a precipitation reaction. So I will write down all the possible metal, I will write down all the possible precipitation reaction for HCl. The first one that we discussed was AgCl. So the product here is AgCl, and it is an insoluble precipitate we are supposed to settle down. So if the product is AgCl, that means the reactant, it must be Ag. So as you know, there are not much compounds of Ag. So and I think this year we will be studying about one more compound of silver. There are not much compound of Ag, because the reason is most of the silver compounds are insoluble in water and silver is not that much reactive. So the most suitable compound that is soluble in water. The problem here is we are supposed to take a silver compound that is soluble in water. So in the last year you have studied that all the compounds of sodium, potassium and ammonium cations are soluble in water. Other than that, there was one more condition, that is this: all the salts of nitrates, they are also soluble in water. So if we are taking, we cannot take any other cations here because that will be, because if we are taking that cation, we cannot add the silver here. So only possible thing that we can do is we can use nitrate as an anion. So all the nitrates are soluble in water. So AgNO3, that is silver nitrate, it is highly soluble in water. So we can use AgNO3 here. So that means if we are taking AgNO3 solution, a solution of silver that is soluble in water, and if we are adding HCl into that, the product that will be AgCl, one of the byproduct, that is AgCl, it will be insoluble in water, it will settle down. Okay, now what will be the other byproduct? Ag, if we react with Cl to form AgCl, so the other byproduct will be H and NO3, so it will form HNO3. In other words, it will form nitric acid. Okay, so this is the reaction. HCl plus AgNO3 gives AgCl plus HNO3. I hope you understood. Now, what is the observation for this reaction? So, there is no need to study this or study the precipitate of all the three, but there is a special case for silver chloride. So, the chloride precipitate, it always be white. Okay, so all the chloride that is precipitating, they will be white in color. Not always, in almost all the cases, especially in the chlorides that you are going to study here. So that will be white in color. AgCl is white in color, PbCl2 is white in color, and the last one, that is mercury chloride, that will be also white in color. So the only thing is that in case of silver chloride, when you are studying, when you are writing the type of precipitate, you cannot write it as just white precipitate. Just like in case of zinc, the name of the precipitate of zinc, it was not white precipitate, it was white gelatinous precipitate. Similarly, in case of Ag or in case of AgCl, the precipitate is white curdy precipitate. Okay, so in all the rest, you can just write it as white precipitate. In case of zinc, it is white gelatinous precipitate. In case of AgCl, it is white curdy precipitate. Now, we are going to do the next reaction, that is the reaction with HCl and another lead compound. Okay, so another lead compound that is soluble in water. So there are only two compounds that I know that is soluble in the two compounds of lead that are soluble in water. One is lead chloride, that is soluble in hot water. We cannot use lead chloride. Can you tell the reason? If we are using lead chloride, what will be the product? Try to do the crisscross method. So you can see here, if you are doing the crisscross method, the product is PbCl2 plus HCl. In other words, it is same as the reactants. So there won't be any reaction if you are mixing two reactants with either same cation or same anion. The reactants are having same cation or same anion, there won't be any reaction. So here, if you are taking HCl and PbCl2, there is no reaction. So what we are supposed to take? We are supposed to take another salt of lead which is soluble in water. Almost all the lead salts are insoluble in water. So the easiest one that we can take, it is a nitrate salt, just like the previous case. So I am taking AgNO3 here. Sorry, PbNO3 twice here. That is lead nitrate. So lead nitrate plus HCl, the product is PbCl2. Okay, PbCl2 it exchanges the anion with HCl to form PbCl2, H and NO3 it will form HNO3. So the precipitate here it will be just white precipitate. Okay. Now there is one more reaction that is with HCl and a mercury compound. We can react it with mercury oxide also, that is also fine. Here also you can use AgO and Ag2O and PbO, that is also fine. Because acid and metal oxides are basic in nature, acid plus a metal oxide it will give the same reaction. So HCl plus AgO it will give HgCl2 plus H2O. Here HgCl2 it will also be a white precipitate. So go to write the downward arrow. Okay. So this is about the reaction of HCl to form certain precipitates or precipitation reactions using HCl. Okay. Okay. The next part in the textbook it is mentioned that it is not there in the syllabus, but I think in the last board exam this question was asked. So I hope you study this reaction at least for the first one, that is MnO2. Okay, that is one of the important reaction. So just as I told before, we have studied about laboratory preparation. After that, industrial preparation is not there for HCl. We have studied about chemical and physical properties now. Now the last part is the specific character. If there is some specific reaction for HCl, we are supposed to study that. Okay, so in case of HCl, there is a specific type of reaction that is only seen in HCl. Okay, so HCl it is able to react with oxidizing agent. I hope you remember oxidizing and reducing agents that you have studied in last year. So HCl it is able to react with the oxidizing agents like PbO2, Cu2O, MnO2. So when it is reacting with this oxidizing agent, one of the byproduct that is most important, that is chlorine. Okay, so from the HCl we are able to synthesize the chlorine gas if you are adding little bit of oxidizing agents like MnO2 into the concentrated hydrochloric acid. We are supposed to keep it also little bit for effective production of chlorine gas. So if this all this reaction it is having a specific observation, that is the evolution of chlorine gas. The chlorine gas it is a pungent smelling gas. It is again a pungent smelling gas like HCl, but unlike HCl, which is colorless, chlorine it is having a specific color, that is it is having a pale green color, okay, or yellowish green color. The problem is this green color of chlorine it is not easily observable. So the only thing that we can observe it is some green shades by the sides of the test tube. Okay, so the experiment is this: take concentrated HCl in a test tube, heat it for a while, then add little bit of MnO2 or any other oxidizing agent into the test tube. The observation is for evolution of chlorine gas. You can see some green layer, green shades on the sides of the test tube. Okay, so I'll just write down the reaction for MnO2. So MnO2 plus HCl, the product is MnCl2. Just like the previous case that we have discussed, whenever HCl is reacting with something, one of the product is chloride. Metal chloride. Okay, so the other byproducts are H2O and the last one is Cl2. So this Cl2 gas, that is the one that is giving the green color. Okay, now so there is only one observation here, that is the evolution of chlorine gas, which is pungent smelling gas, and also it will give some green. It is the evolution of greenish yellow gas. So other than that, there can be one more oxidizing agent that can be asked in the exam, that is Cu2O. Okay, so last time we have discussed with CuO and Cu2O both are different. Okay, so what is the difference between CuO and Cu2O? Here Cu is in plus state, here Cu is in +1 state. Okay, so this one Cu2O, or in other word cuprous oxide. This is cupric oxide, this is cuprous oxide. The cuprous oxide, it is an oxidizing agent. So when we are treating with Cu2O and HCl, you will get CuCl2, that is little bit blue or green in color. So other than the evolution of greenish yellow gas or green pungent gas, the solution of copper oxide, the solution, it also turn into a blue color solution. Cu2O, it is black in color, it will turn into a blue color solution. That is one more solution. These are not that much important, but at least study the first reaction. This is important. It is commonly asked in the previous board exam, but now it is written not in the syllabus, but still just go through this reaction, study this reaction. It is important. Even if you are not studying it now, next year, when you are next year means when you are going to +1, during your analytical chemistry, in your practical chemistry, in organic practical chemistry, you are supposed to study the same reaction. Okay, so I hope you will remember this reaction. The next one, it is the formation of aqua regia. So either I will take it. So I will take the formation of aqua regia now. So I won't be explaining anything about the aqua regia in the upcoming chapter, that is nitric acid. Okay. So next one that we are going to discuss, it is the aqua regia. So this part we won't be discussing again in the nitric acid chapter. So aqua regia, it is 3:1. This ratio is always asked in the exam. Aqua regia, it is 3:1 ratio mixture of HCl and nitric acid. Or in other words, 3 HCl, 1 HNO3. So we are mixing nitric acid and HCl and nitric acid in 3:1 ratio, or nitric acid and HCl in 1:3 ratio. Don't forget this criteria. 3 is for HCl and 1 is for HNO3. This is usually asked in the exam, even though it is placed along with the part for reference only. You are supposed to study this also. So what happened when HCl and nitric acid react? 1 HNO3 and 3 HCl react to form. So NOCl, this one it is called nitrosyl chloride. Along with that, H2O, and what is this? This is called nascent chlorine atom. So last year when you were studying the chapter atmospheric pollution, you have studied about nascent oxygen atom. Just like that, this is nascent chlorine atom. It is a highly reactive and highly oxidizing agent. So nascent chlorine is produced here. So this is the reaction between nitric acid and HCl. The product formed is nitrosyl chloride, H2O and nascent chlorine atom. So you just have to keep this in mind. You are supposed to study the reaction also even though it is not there in the syllabus, it can be asked in the board exam. It is one of the important questions. You can write this as one of the use of HCl also. HCl is used to prepare aqua regia. So what is aqua regia? Aqua regia is the 1:3 ratio mixture of nitric acid and HCl. When nitric acid and HCl are mixed, the following reaction takes place and it will form nascent chlorine atom. Now we are going to discuss what is the use of this aqua regia. So the aqua regia, it is used to dissolve, or it is used to react certain metals, or in other words, it is used for the formation of compounds for certain noble metals. So what are noble metals? There are three main noble metals. The most important one is platinum, the second one is gold, and the last one is silver. So these three metals are called noble metals because even though they are metals, even though they are not noble gases, even though they are metals, they won't take part in normal chemical reaction, or they are formed as pure substance in the nature. Or in other words, you already know that gold, it is not easy for gold to react with any other compounds. It is not because of octet rule or any other stuff. It is because of the stability of gold. So gold normally exists in pure state, or in other words, you can get the pure gold as such instead of, for example, in case of iron, it will be existing as iron chloride or iron oxide or some other compounds of iron, but in case of gold, it will be pure gold, not any compounds of gold. Okay, so to make some compounds of the noble metal like platinum and gold, we are using aqua regia. Or one more thing is to produce, or to what you can use. Okay, for electroplating of gold, for electroplating of silver, we need certain gold compounds, or we need to dissolve gold in certain compounds. Especially in electroplating of gold, we are using aqua regia to dissolve gold into the electrolyte solution. For that purpose, so aqua regia, it is used for preparation of compounds of gold and platinum, and also for electroplating. It is used for the electroplating of gold and platinum. Okay, so now with that, almost all the reactions of HCl is over. The next is uses and tests for HCl. So first we will go for the test for HCl. So this test for HCl is important. I think there are in the last board exam there was many observation type questions. They will give the reaction. They will ask you to write the observation for that reaction, and also they can ask you directly what is the chemical reaction when these compounds are reacting. Okay, now the most important test for HCl, it is this. So we are supposed to take hydrogen chloride, not hydrochloric acid here. So if by any process we could produce HCl gas, or if you are taking concentrated HCl and if you are heating it for a while, we get the HCl gas. Then what we are supposed to do after? We are supposed to bring a glass rod. Okay, so we are taking a glass rod. We are going to immerse that glass rod. Take a glass rod, immerse it ammonium hydroxide solution. Okay, so take a glass rod dipped in ammonium hydroxide solution. If it is both near the HCl vapors, you can see dense white fumes. Okay, so that is due to the formation of NH4Cl. Okay, so NH4OH plus HCl will give the product NH4Cl plus H2O. Now, what is NH4Cl? It is a base. You have studied in the analytical chemistry chapter, NH4OH, it is a base. So since NH4OH it is a base and HCl is an acid, it is an acid-base reaction. So the formation of the product, we can analyze it as salt plus water. NH4Cl is the salt, H2O is the water. So as you know, the reaction between an acid and a base, it is always highly exothermic in nature. Acid-base reactions, they are highly exothermic in nature. Now, in this reaction, the product form, that is H2O, it is in gaseous state, and NH4Cl, it is supposed to be formed as solid. Okay, so NH4Cl, it is formed, NH4Cl that is formed in this reaction, it is supposed to be formed as a solid, but there is something that you have studied in the previous chapters. NH4Cl is one of the compounds that are easily sublimable. What do you mean by sublimation? So if you are heating a solid, if it directly converts itself into gas, now instead of converting it into liquid, it will go directly into the gaseous state. It is called the sublimable substance. Okay, so NH4Cl is a sublimable substance. So what happened here is, when a glass rod dipped in NH4OH or ammonium hydroxide is brought near HCl gas, NH4Cl is produced. It is produced as a solid, but the problem is HCl plus NH4OH, acid plus base reaction, that is highly exothermic in nature. It will produce a large amount of heat. That heat is absorbed by this ammonium chloride. Since ammonium chloride is a sublimable substance, what happened? Ammonium chloride undergo the sublimation process. Because of that reason, it will convert itself into gas. So ammonium chloride is the one that gives the dense white film. So in other words, if you are bringing a glass rod dipped in ammonium hydroxide near HCl gas, you can see dense white fumes of ammonium chloride. Okay, so I hope you understood this. If you are bringing a glass rod dipped in ammonium hydroxide near HCl gas, you can see dense white fumes. You have already done this experiment in your 9th class. I hope you remember. Just the opposite is also possible. If we are bringing a glass rod dipped in HCl, hydrochloric acid, near ammonia gas, you can see the formation of ammonium chloride again with dense white fumes. I hope you remember. We will do that once again later. Okay, so that is the first test for HCl. Just bring a glass rod dipped in ammonium hydroxide. The observation is dense white fumes of ammonium chloride. You are not supposed to write just dense white fumes are observed. You are supposed to write it complete. Dense white fumes of NH4Cl, it is observed. Okay, so the first test, it is the reaction between HCl and NH4OH producing dense white fumes of ammonium chloride. Now we are going to the second test. So the second test, this one we have already discussed as one of the precipitation reaction of HCl, that is this NgNO3 plus dilute HCl. So if we are adding dilute HCl to AgNO3 solution, the product is AgCl plus HNO3. So AgCl, as you remember the previous reaction, it was a precipitation reaction. So since it is a precipitation reaction, AgCl precipitate will be formed. What type of precipitate will AgCl will be formed? It is not just white precipitate. What was the specialty of that precipitate? It is called white curly precipitate. So if you are adding dilute HCl to AgNO3 solution, you can see white curly precipitate of AgCl. That is the second test to identify the presence of AgCl. HCl. So this is to identify. Here we have to take the dilute HCl, not hydrogen chloride gas. So we are supposed to mix AgNO3 solution with dilute HCl to get the vinyl acetate of AgCl. Now the last test that also we have discussed before, that is the reaction of an oxidizing agent with HCl. Just now we have discussed. The oxidizing agent that we are using is MnO2. So I hope you remember what was the reaction. At MnO2 plus HCl, we are supposed to take concentrated HCl and we are reheat it also. And after that, if we are adding MnO2, the products that we are obtaining are MnCl2, that is manganese chloride, plus H2O, and the last product that is more important, that is Cl2. Okay, I hope you remember what we just studied. Cl2, it is a greenish color gas. So the observation is a greenish color gas which is having a pungent smell is evolved. Okay, so I hope you remember these three tests for the identification of HCl gas. Other than that, there is one more that is given, that is identified by the smell of HCl. The smell of HCl is irritating, pungent smell. So that is also another way to identify the presence of HCl gas. Now, the last part of this chapter, it is the uses of HCl. So HCl, as the uses of HCl, you can write it as such. It is used as an acid. It is used in laboratories. It is one of the important reagents for many of the chemical reaction. Other than that, it was actually used. Okay, there are certain other uses, like it was earlier used as toilet acid, but I don't think now they are using it because it can corrode, it can react with the tiles and other ceramic. Now, the industrial use, they are little bit more important. Okay, so just now we have discussed it is used for the preparation of aqua regia. So to prepare the compounds of gold and silver for electroplating of compounds of gold and platinum for electroplating of gold and platinum, we can use aqua regia, or in other words, it is used HCl is used for that purpose. So it is also used for production of chlorine. Just now we have done a reaction for chlorine, right? To produce chlorine from HCl using MnO2. So it is also used for manufacture of chlorine and other chloride. HCl is the source of many chlorides. Okay, but I cannot fully agree with that point. There is a better source for chlorine. What can you guess? What is the better source of chlorine other than HCl? It is NaCl. So almost all the chlorides are formed from NaCl. Even HCl, it is normally manufactured from using NaCl itself. Other than that, there are many other uses. Just go through that. It is used for galvanization, making of glues, paints. Okay, just go through that. Just study at least 2-3 uses that you think suitable. Okay, I think with that, this chapter is over. I hope you are going through your revisions by yourself, and I hope I can upload this chapter as soon as possible. Okay. The next chapter that we will be discussing, it is not a next chapter, it is actually the continuation of the study of compound, but instead we are going for the second part, that is ammonia. The first part was HCl, the second part or the part, it is ammonia. So you have studied little bit about ammonia and ammonium ion in the first chapter, and also some of the reactions of ammonium hydroxide in the analytical chemistry chapter. You have studied not in the first chapter, in the second chapter, and also in analytical chemistry chapter. So I want you to go through all that, whatever we have studied until now in the previous chapters. Before going to the next chapter, you are supposed to study the orbital structure and electron diagram of ammonia. So I hope you remember the lone pair, and I hope you remember that ammonia is one of the polar covalent compound. It is having 3 covalent polar single bonds, and it is also having one lone pair. Because of that presence of one lone pair, it is able to abstract hydrogen. It is able to abstract the proton by donating its by sharing its lone pair through a coordinated bonding to form ammonium ions. So I hope you will study that part also. Other than that, just go through the introduction part of ammonia also. So this chapter, it will go almost similar as the previous chapter, but in the previous chapter you have studied laboratory preparation, but there was no industrial manufacture. Here there will be industrial manufacture as well as the laboratory preparation of ammonia. And also this is a little bit lengthy chapter compared to the HCl chapter. There are many reactions, almost all the reactions are important. So it is one of the difficult chapters, or in other words, it is one of the important difficult chapters in this entire textbook. So I hope you prepare well before we start the next chapter. As you can see, this is one of the lengthy chapters. Even though it is only some 5-6 pages, it will take a lot of time to complete this chapter. So I'll take my time to complete it properly. So I hope you will go through the previous part that we have discussed, and also I hope you are doing your revisions properly. Homework also, I suppose you are doing that by yourself. At home, if there is any clarification, we can do that when you are coming back to the school, but still try to do by yourself. Try to do everything by yourself. Try to find the answers. You are having your internet connection, so you can search your answers also. And I think almost all the questions that I have given as homework, the answers for that question will be there in the note itself, or it will be there in the online section. Okay, so you can try answering that from the textbook also. It is as you decide. Okay, with that I'll conclude today's session. Thank you.